Everyone, let's start off. Just give me a minute. I don't know why today it is glitching. Yeah, let's start off. So last thing we did was a disk. Next thing, the next shape you will encounter is a solid sphere. Others, do keep your cams on. So whenever you look at a solid sphere, again, see, I can't draw a solid sphere on a paper, so it looks like a disk only. Radius r. So how do we choose elements? Like I said, every time you take a shape, the most important thing is how do you choose elements for this? So there are two ways you can actually choose elements. So one element is like this. You can take a shells. Ever seen an onion? When you open an onion, you'll see a layer upon layer, layer upon layer. So one way of choosing elements is shells. Right? The second way of choosing an element is by taking thin disks. You're getting how is this? You can take thin disks like this. And if you add all these disks, won't you get a full thing? Imagine like this. Take a watermelon, cut it horizontally. You will get a slice, isn't it? So if you put disks, small disk, big disk, and so on, you can take elements like disks also. So these are very thin disks. Getting it? So here elements are this. We will see both the cases in two different ways. Right? So let's try to find the volume of this guy. So here it's like an onion layers. So let's try to find the volume of a sphere. So take a full sphere. Now in the full sphere, at a distance x from the center, consider a thin shell. Now again, the elements will look same like a disk because I can't draw a 3D figure on a 2D. So you have to visualize this is a 3D thing. So this is like a thin hollow shell. So what we get here, quality balls ka, you get a ball ice cream. You get a ball, you can open the cap, eat all the ice cream and put it back, you get a ball. It's like a balloon kind of thing. Inside it's all empty there. So we got a thin hollow shell. Of radius r, of radius x. Thickness is dx. So the volume of this thin thing, so dV is the volume of this thin shell is nothing but the surface area of the shell into thickness. Do you guys agree with that? Area into thickness will give you the volume. So the area of this thing is 4 pi x square and thickness will be dx. Any doubts on this part? So take the full surface area and remember the thickness is so small, I can assume like it's like a flat thing and multiply into dx. So if you want volume of a sphere, I just have to add all the volumes of this thin sphere. So integral dv. Where is the first shell starting from? Your first shell is starting at center and the last shell ends at x is equal to r. So your limits will go from 0 to r. So this guy will be 4 pi x square dx 0 to r. That is x square ka integration, 4 pi will come out. This will be x cubed by 3, 0 to r. So this comes out to be 4 pi by 3 r cube. This is the volume of a sphere. Which part, Aditya?
So, so
You have to be every time specific with your doubts. When you say,
Yeah.
sir, explain, it doesn't make sense. Be specific. Which part?
all right. So after you take a sphere and then you cut it from the middle. Is that what we're talking
Where?
about?
What are you even talking about? You missed the whole point. You're not there from the beginning?
I will.
Okay, listen, we are taking shells. These are not cutting in the middle. This is a 3D sphere. I can't draw a 3D sphere on this thing. So this is like a shell, a hollow ball. It's a hollow ball if you're looking at my screen. So if you're taking a hollow ball of radius x, whose thickness is dx. So for a sphere, what is the surface area? 4 pi x square.
Oh,
So this hollow ball ka surface area is 4 pi x square and thickness of the ball is dx.
okay.
If you multiply area of the ball into dx, you'll get this thing. What did you think? You thought I cut the ball like this?
Yeah.
Nah. Problem, I can't draw a 3D sphere, no? That's the thing. Maybe, I don't know. Can I try drawing it? Let me see. I don't think I'll be able to, but this is a 3D sphere I have. So we are taking element again. The problem is that only if I try to draw something like this, so it's like a thin shell here. But I think you got it now.
Yeah, understood.
Yeah. No, that you have to visualize because 3D things we can't draw on 2D. At least I am not a pro in painting, so yeah. Last time I drew a horse, it looked like a dog, so yeah. Anyways, is the volume thing clear? Any doubts on how did I get the volume again? So the main thing, you took a thin shell of radius x. So the surface area of this guy is 4 pi x square. Surface area into thickness is volume. So this thing is the volume of the thin shell. So if you add all these volumes, I'll get the full sphere ka volume. All got this? So if you see now, we encounter these kind of questions. Recently we did this, and so there was a question like this. Here you can see. So we are trying to find some charge of a shell or something here. So these integrations keep popping up. This will be like a normal part of an integration later on. You will see this in multiple places. We saw this even in electrostatics also. You will find a lot of elements, rings, and everything. So, but let's see a question on this. Last time we did mass, na? Same way. Let's say we have a sphere, a non-uniform sphere. Ever seen a Kinder Joy? It's actually a non-uniform thing. In the center, you have some other filling. Outside, you have some other chocolate, something of that sort. So rho is given by, let's say, 2 into x, where x ka value lies between 0 to r, right? So here, this rho is your volume density. This is the density which you studied in school, mass per unit volume. Meaning, if someone tells you rho is 100 kg per meter cube, so every 1 meter cube has 100 kgs of mass. So here, this is a variable density. Look at this thing. When x is 0, there is no mass. When x is increasing, the mass increases. X increases, mass increases. X increases, mass increases. At the outermost, you have the highest mass. This thing is looking like the Disca thing, isn't it? But this thing is happening in 3D. Yeah? If you're looking at my screen, it is like this. Center where you don't have any mass, then you have little mass, more, more. So as you go out, it is becoming heavier and heavier and heavier. If you look at this, Earth is reverse of this. Earth, right, outside is light. As you go into the Earth, it becomes denser and denser and denser. The center of the Earth is more denser. It is molten iron, right? So here the density decreases as you go away from center. Can you find the mass of the sphere? So you brought a sphere whose density is not constant. If it was constant, your life would have been easy. You could have taken rho into 4 by 3 pi r cube and done. You got the answer, isn't it? If the density is not constant, you can't directly say density into volume. Okay, let's see. Right, Arya. Right, Shreyansh. We have two answers, everyone. Get it, get it. Right, Samyak. It's the same question here. You just have to multiply density into dV and then you do it. Try. Others try. I'll give you a minute. I'll show you. See, the same story. Take a sphere. Since the density is changing, I can't directly do it. I will take a thin shell. Ever seen a balloon? When you fill it with air, how thick is the balloon ka skin? The rubber sheet is very thin, isn't it? So think of like that. It's a round balloon filled with air. So it is very thin. So this radius is x and the thickness is dx. So the volume of this thin shell is surface area 4 pi x square into dx. This is just now what we did. So mass of this thin shell. Now, because the density, dx is so small, I can assume it is almost constant. It will be density rho into volume. The formula is still the same thing, density into volume, but I can't use it over the full sphere. So this will be the volume of shell and density of shell. So density of shell is 2x. Volume of the shell is 4 pi x square dx. So this would be the mass of this thin shell, 8 pi x cube dx. So if you want the total mass of the sphere, I have to add all these shells. Adding meaning integral, means summation. Limits will go from 0 to r. So 8 pi integral x cube dx. This is what I was saying. The actual integration is easy. The headache is converting it. This would be 8 pi. That will be r power 4 by 4. 2 pi r power 4. Is this making sense, everyone? Didn't we do something like this for the disk? How are we?
Sir, in the previous, like when you showed how you took
The volume.
Like, I mean, we can take the disk also, right?
Disk भी ले सकते हो.
But when I tried integrating it, I'm getting 2.
कर दे. We are going to do it next. Why? It's coming up. That was a little difficult. So Shells are the easier one and most commonly used. Discs come rarely, so I kept it for the end. We'll do it.
सर हमें
Any
टू
doubts on
टाइम्स
this?
करना पड़ेगा ना उसको
Sir, I got it.
Q?
सर लाइक आधा पार्ट का डिस्क ऊपर
Sir,
कम हो रहा है
I too
आधा
have-
नीचे हो रहा है
वो depends on how did she take the elements. मतलब देखते हैं. I'll show you now.
Sir, I got it.
Got it. Okay. Ananya, clear with this? Shreyan, you got this thing, na? Shreyansh. Ishman, got it? Shaunak, Sudiksha, Yashvi,
Yes.
clear? Vanchika, Trishi. Great. Now, if I have to ask a good question, suppose if you have a hollow shell, someone filled it with water. This height is h. This is the center. This is radius r. So someone filled the shell with water up to height h. Find the volume of water. Now, if it is completely filled or half filled, we know. What if only fill it till part? Find volume of the water. Now here I can't use shells. The only element you can take is discs. This would be a good one. And later on, when we see it later on, I'll ask you something called center of mass of this part, moment of inertia of this part. That would be an advanced question. But for now, let's find the volume of this water. Let me ask you something. Listen carefully. Listen to this thing, everyone. This is important. If suppose this comes in the exam, are you not listening? If suppose this comes in the exam, right? And I don't know how to do this. And luckily in the exam, we have 4 options. How do we eliminate the options? This is an important skill. You know, I'll tell you again, see, just because you think your subject is good doesn't mean you'll score in the exam. When I was in 11th and 12th, one of my friend, right, his name is Sabir. He's the guy who taught me a lot of concepts in physics. He's very good in physics. Getting it? He never scored more than me in physics. Getting it? When we wrote AIEEE exam, it was 180 questions in 180 minutes. It's a pretty fast exam. My all India rank was 185. His rank was 9,000. Advanced my rank was 360. His rank was 670. So as the paper started becoming tougher, he started performing better. The reason is simple. Sabir is very bad at guessing. You give him a question, he will be like, wow, such a nice question. The examiner really thought about it. He appreciates the question in the middle of the bloody exam. Are chupchap solve karna. After the exam, you appreciate the question, right? So this guy is fine. Matlab, he loves physics, he appreciates it and all. So you need to be very clear about that. This is the truth. Huh? When you are not in the exam, the only important thing is concept. In the exam, the only important thing is marks. It doesn't matter how you got that answer. No one cares. You will get +4 for it. So if this question comes in the exam, how will you solve this without solving anything? Any ideas? And this is a very important skill. Every year we normally do this thing. I try to keep 1 or 2 exams. When the portion gets over, I did that for your seniors. There is one paper where you have to just guess all the options. You're not supposed to solve anything with pen and paper. Because think about it. If you, every paper, if you can even guess 4 questions out of the full paper, advanced thoda difficult I guess karna. Mains is possible, CET it's possible. I'll just tell you one question in max. I guessed when I was there. I still remember that so clearly. It was a big question, 6 lines ka question. And it was like integral x by root or something, blah, 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 blah. Everything was asked. And the question was find mod x. Options are -1, -2, -3, and 1.
1. It would be
One, sir, one.
ना बस हो गया ना, discussion close. मतलब I just went through the question, I saw the options, I said one, I said bloody what kind of question is this? So CET people do such dumb things. Getting it? But if it is Sabir, na, he will literally try to solve the whole thing and he will spend 5 to 7 minutes. Not wrong, but you are wasting time, isn't it? This happens. This is the reason, most people think this way, sir, I'm studying a lot, I'm solving a lot of questions, but I don't score. That is because writing an exam is a different skill set. Just because your subject is good doesn't mean you'll score. Unfortunately, entrance exams are like that. Because I have seen really good students, who are very bad at guessing or who are bad at figuring out, yaar, ye nahi ho sakta hai. That instinct comes, when you do a lot of practice. And this skill can be developed. This is not natural. So every time when you solve questions, after reading the question, just wait for 15 seconds and ask yourself, is there any way can I guess this? If you can't guess in 10 seconds, go ahead with solving. I still do this. You give me a question, first thing I'll think, can I guess this? I'll show you later on. Most of the times when it comes, I'll keep showing you this. But it is a skill you can learn. So this is the first question I'm showing you. Like, how can I guess this? If this question comes, how will I guess this? Any ideas? Think, I'll give 30 seconds. One way to do is inky, pinky, ponky, father is a donkey, and we can say that, but that doesn't work. Head or tail. So when I say guessing, now understand, it should be a logical guess. You can't do just random guessing. Huh, Didi?
Should we just consider like the hemisphere that it's the water ka volume?
I don't care. You just tell me what to do. You're asking me, you're not telling me.
Sir,
You're gonna have to give me a second.
Think,
Sir.
Arya.
sir, it should be dependent on H and R in such a way that the
सब में
volume
H and R
part-
सब में है.
Sir,
सब में है.
options दे सकते हो आप?
नहीं.
सर 1 डाल के देख लेंगे सब.
1. उसमें क्या होगा? Let me ask you something. So whenever you have to guess, right, the best way to guess that I have observed is this. You change the question. Because the examiner, right, will always give the options in such a way you can't guess. But if you change the question, most of the times you don't expect that. So this is how you change the question. What if H is equal to 2R? If you put H is equal to 2R, can you tell me how will the diagram look like?
Full water.
It's a
is
fully filled sphere, right?
Yeah.
Then what should be the answer?
It should
4
be
by 3 pi
4
r
by
cube.
3 pi r cube.
So I will keep H is equal to 2R in all the options. I will see who is giving 4 by 3 pi r cube. Most of the time, 2 options will get eliminated. You will be still stuck with 2 options. Is that making sense logically? See, when you guess in the exam, now you should be 100% sure. So if you put H is equal to 2R, answer should be 4 by 3 pi r cube. See who is giving that answer. Whoever is not giving is wrong. It doesn't mean others are right. We don't know. So you're actually trying to find the wrong answers. What else can I do? If I put H is equal to 0, how much should I get? 0. I think mostly you still can't eliminate. B and D will give 0. What else can I do?
Half. You can put half.
Half. If I put H is equal to R, it will be half filled. Then what should be the answer?
2
2 by 3 pi r cube. If it is a mains exam, 3 options will get eliminated. Advanced exam, you'll be still stuck with the 2 options. Now to Gaya, you have to solve. So that is there. That is always a catch. Advanced papers generally that I noticed, you can eliminate up to 2 options. It's very difficult to eliminate 3 options in advanced paper. Mains में हो जाता है. Mains
we can
में
even get a clue from the it's the non-eliminated options for solving the question.
you can, but sometimes क्या होता है ना, we overthink and we mark the other one. So it depends. Meaning I could never guess like that randomly. मेरे साथ कभी नहीं होता था.
So
I'm very
like,
bad at guessing.
उसका integral ये दिख रहा है ऐसा.
Telling you now that now let's see. Now try to solve. But did everyone got an idea how to approach a question? This is how you think. You try to modify the question. And see, this is a very logical way of guessing. We are not doing some random guessing. If it is a mains exam or bits exam, you'll get an answer. I have seen bits and mains में हो जाता है maximum. Maybe not all. If there are like 25 questions, you can maybe guess 1 or 2. It might not look like big, but trust me, 3 hours exam, when you're under tension and you got an answer in 10 seconds, it will give you a pretty good confidence. It will boost you. It feels good. And feeling good in the exam is very important. And if you can do at least 3 questions, if you can guess in 20 seconds, you're almost saving 1 hour, 1 minute, 30 seconds on each question. So you have around 4.5 minutes more. So you can solve at least 1 or 2 more questions in some other subject. And that one question of 4 marks can make a difference. You can get into IIT Bombay or IIT Guwahati. I have seen that 4 marks, 5 marks will make a hell lot of difference sometimes. There was one kid I remember last year, medical mein hua tha. She lost a seat in Mumbai by 6 marks. She was getting somewhere in some proper village tha wo. Somewhere in borders of Maharashtra. She didn't want to go there, obviously. So the dad has to pay 25 lakh donation in Mumbai and get that seat. So the 6 marks ka cost was 25 lakhs last year in medical. How do we do this? And ranks keep blasting off. Meaning, I'll just give a little statistics here. Last year, this year, advanced result aayega 2 week mein, we'll see. Last year, one of your senior got 175 out of 360. His rank was 4,300 something ish. Another student got 155. The rank was 8,400 something ish. 20 marks, your rank went away almost 4,000. This is what will happen with that one question. So it counts. Every question counts. More important than that, it makes you feel good. Let's see, how do we try this? So we have to take a disk. That is the idea there. By Samyak, you got an answer, na? Abhi usme h is equal to 2r dal ke dekho. Are you getting 4 by 3 pi r cube? That is the easiest way to check your answer. Whatever you got, put 2r and see if you're getting 4 by 3 pi r cube. Should I help you with the element? I'll help you with the element and then I'll give you another 2 minutes to try C. So we'll take a sphere. Let's take a let's take a thin disk. Like this. That picture is not looking good. I'll just shade it to the side. I think now it's better. So from the center, let this height be y. And let this distance be x. And this is the radius r. You can clearly see Pythagoras. This is x. This is r. So r square is equal to x square plus y square. Keep this aside. We're going to use this. You're getting it somewhere? Okay. Now, this disk which I took, now see, this is how you always choose an element. This is radius x. So while you're coming down, what did you do? You're traveling a small height dy. Are you getting this? This is dy. The vertical height is y. So from here, if you travel a little forward, isn't this dy? So the thickness of the disk is dy and the radius of the disk is x. Is that making sense, everyone? So the volume of this disk, now see, if you think about it, this is like kind of like a thin cylinder. This is like a thin cylinder. If you have radius r and height h, the volume of the cylinder is pi r square h. So here the dV, volume of this thin disk, will be the radius pi x square into dy. Agreed? Is that clear, everyone? Now, but what is x square? I know x square is nothing but r square minus y square. If I substitute here, I'll get pi into r square minus y square into dy. So the volume of the water will be integral dv. So I have to just integrate this. So far clear? Any doubts on this? So I found the volume of the thin disk, the radius is x and the thickness is dy. So it is kind of like a cylinder. So volume is pi x square dy, but I know x square is r square minus y square. I substituted there. All clear with this? Now, just look at this y coordinates now. I'll just redraw it again. So initially the water was filled till here. And you have taken y is the distance from the center somewhere. So you have taken a thin disk like this. So at the center, y is 0. So if you're coming down, this point y is equal to r. Remember, this was h. This point y is equal to r minus h. That means when you took the y coordinate, so y is the distance from the center. So you tell me, the water started from what coordinate? The water started from r minus h to r, isn't it? The water level started from r minus h when y is at a distance of r minus h, and the water ended when y is equal to r. So the volume of the water is integral dv. So this is the thing about limits. So you're starting from r minus h, you're ending at r. Is everyone clear with the limits? The upper surface of the water ka y coordinate and the last corner ka y coordinate. Huh, Aditi? Clear? I'm just asking. Is this clear? Huh. So what is dv? So dv is this guy. Bring it pi r square minus y square. You're done actually. The integration is actually easy. The headache was getting till here. So this was r minus h to r. R minus h to r, and this is pi r square minus y square dy. Any doubts on this step? Anyone not clear? Please ask on this page. So I just have to integrate this guy, pi into r square minus y square dy. And the limits will go from r minus h, the starting point, to the ending point r. Sure? Then this integration, we will be, pi just comes out, throw it out, integral r square dy minus integral y square dy. The limits are little bad, r minus h to r minus h to r. Integrate this. So r square is constant. So this will become r square y. Integration is over. Limits are r minus h to r minus y cube by 3. Limits are r minus h to r. Simplify this, pi. This is r square. Substitute here, put r, and then put r minus h and subtract them. Minus r cube minus r minus h whole cube by 3. We need to simplify this. It looks bad, but once you get down the whole thing, it's actually kind of easy. So this r and this r will cancel. So you're just left with h there. So pi r square h minus 1 by 3. This will be r cube minus r minus h whole cube is r cube minus 3r square h. A minus b whole cube expansion, everyone. 3r h square minus h cube. In this r cube and r cube term cancels off. You are left with pi r square h minus 1 by 3. The minus goes inside, you'll get 3r square h minus 3r h square plus h cube. Divided by 3 there, you end up with pi r square h minus r square h plus r h square minus h cube by 3. This guy goes off again. You end up with pi. Take out h square common. You will get r minus h by 3. You can multiply this. So 1 by 3 pi h square 3r minus h. Again, one thing I'll tell you, see, the moment you have written this statement, physics got over, isn't it? The answer looks bad and dangerous, but if you see, it is only just substitution. Arams, if you substitute the values, you'll get everything cut. Have a look at this. This is the volume of that part. And for your verification, we can check. If I put h0, I'm getting 0, right? If I put h is equal to r, I will get 1 by 3 pi r square into 2r. Yeah, I'm getting 2 by 3 pi r cube. If I put h is equal to 2r, I'm getting 3r minus 2r is r. Yeah, I'm getting 4 by 3 pi r cube. I'm getting all the answers. Obviously, you should get it. Now, did you notice something? Till now, we learned how to find volume of a full sphere or an half sphere. But now you know volume of a sphere, no matter to what height it is filled, isn't it? These things we couldn't have done before. Without integration, this won't have been possible. So it's a pretty good answer. You can kind of remember this. So the volume of this is 1 by 3 pi h square 3r minus h. This is how you'll get questions. I think Samyak got this. Arya, clear with this? Anyone else? Anyone not convinced with any particular thing? The main thing is getting the element and getting till here. Then it is simply x power n ka integration. Any doubts on this? So you can take discs like this also. How? Yeah, clear with this? Now let's see one more one. Every time you might not get a disc, you might even get some other shapes like a paraboloid. This is a thing. This will come at least once or twice. So a paraboloid, it's a parabola in 3 dimension. So look at my screen. It's like you take a parabola like this and you rotate in 3D. The shape which you get is like a bowl. You're getting it? It's called a paraboloid, 3-dimensional parabola. So let's say the bottom point is the origin. It's a solid paraboloid, not volume. And let's say this equation is y is equal to ax square. I can get the limits also. Wait, I'll show you. The upper part ka radiuses are. This height is h. So if I take h is equal to a into r square, h by r square. So this equation, y is equal to h by r square into x square. This is the equation of this curve, everyone. That is the equation of that curve. So find the volume of this paraboloid. Let me show you how this would actually look like in 3D. There, this is a paraboloid. Can you see this cup? You know where else you see this shape? If you put water in a bucket and rotate with your hand, or if you put water in a glass and rotate it, did you ever see the bucket ka shape? The water becomes like a bowl kind of thing. That's actually a paraboloid. When you rotate water in a bucket or in a glass, the shape the water forms is actually a paraboloid. Look at this thing. I don't know if that is clearly visible. So you will get a shape like this. Let's see if I have one more better picture than this. I think this is a little better. So this is the water in a rotating bowl. Is the picture clear, everyone? So this thing would be like something like this. This is the shape it is forming. So this is a rotating fluid. If you rotate this, the shape you get is a paraboloid. Try. You get a pretty neat result. And this will come up. You're going to use this equation in fluid mechanics. Anyway, don't worry, you'll forget this. I'll teach you then. So we have a rotating bowl here. The question was this, find the height and everything. So we actually do the volume of a paraboloid and then we actually calculate all that stuff. That is a 4 pages ka question. In that this paraboloid is a small part. No worries, you'll forget this for sure. By kahan se aaya re yaar? Yeah. Answer comes in terms of R and H, right? How to start? I'll just help you a bit. Say, you'll take discs, isn't it? Take a thin disc. Then you take thin discs. So you're making discs like this, chota discs. If you add all these disc volumes, you'll get a full paraboloid. Arey, did you ever cut, this banana potato chips? Isn't that how you do actually? You take a big potato and you start slicing this. The discs you get, won't you get discs like this? So when you're taking a potato and you're slicing continuously to make chips, what you're getting is discs only, isn't it? There. So you actually used integration without knowing it in while making potato chips. By R power 4. नहीं रे, dimensions match नहीं हो रहे थे. Did you see how many ways I can tell it is wrong? I can't tell what is the right answer, but I can tell when it is something
Sir,
wrong.
I mixed up the X and Y integration together.
Yeah. Exam में वही होता है. This is what I'm telling you, this is a skill. The moment I see, I can tell अरे ये wrong है. कुछ तो गड़बड़ है. I don't know whether it's the right answer, but I can see blunders. How do you think your seniors can solve in 1 hour 80 questions? Think. I'll give another minute or two. Give it a try. It's completely fine if you don't get an answer. I don't care about your answer. I really want you to try how to choose an element. What is that? Anything. Do anything. Try for 1 or 2 minutes. And then I'll show you anyway. You can verify. Just give it a try. I'll get some water and come. Oh yeah, you got it. Samyak, you got it. Did you notice that answer you got is something? The answer you got is a very nice way to actually looking at that answer. Whenever you see this, you can remember something. कुछ लग रहा है वो आंसर देख के? There's a very beautiful thing there in that. If you remember that, there is no need to integrate this anytime in your life. Think about that. Others, let's see how to do this.
Sir, it is half the volume of cylinder.
बोलना नहीं चाहिए था. You should have typed. So see, because of you, you will not think. See, Samyak is smart. He's making sure others don't study well. That is also a good way to improve your rank. You can study well and mess up other ka studies. So we got a thing like this. So we are making potato chips. I think the potato chip example clicked, I guess. See, if you can explain anything in terms of food, people understand really well. So that way. So if you take a small potato slice, so this is how the disc will be. So this is at a height y, the thickness will be dy, and the radius will be x.
So do we have to differentiate?
नहीं रे, तो क्या कर रहे हो?
Sir, I use dy by dx to find dy in terms of dx and then.
चलो देखो सुनना, इतना नहीं करना था. So this guy was x and this guy was dy. See, even though I changed the shape, the story is still the same. You get the exact same thing. So this is a small cylinder. This is a small cylinder. So the volume of the cylinder is pi into x square into dy. Agreed? Did I change anything from here to this? Didn't I do the same thing here? This is what I'm saying. When you see an element, right? Luckily, you need not study too many varieties. The elements will always come the same. And it is given in the equation y is equal to h by r square x square.
And how did you make that expression up in your mind when you were doing the
Which
question?
one?
This h by r square.
You know, it will be parabola, na? Parabolas are in the form of y is equal to x square. So y का coordinate h और a का coordinate r. तो a का value आ गया, डाल दिया वापस.
Okay.
So what is x square from here? So d into pi x square is y into r square by h into dy. You're getting what I did? I simply took x square from here and dumped it in this. हो गया, देखो, there's nothing there. This is pi r square by h into y dy. It is a very simple integration. So your y ka coordinate at the bottom is 0. At the topmost point, y ka coordinate is height h. So this volume of the paraboloid integral dv, limits will go from 0 to h. This is pi r square by h integral y dy, 0 to h. That turns out to be pi r square by h into y square by 2, limits will go from 0 to h. Substitute here, you end up with pi r square h by 2. हाँ हो गया.
I understood that like the disc we took, it's like a small cylinder, but why did we get the volume as half of the cylinder?
That, why we got this, that is a thing. For that, I don't have an explanation, but we get it, half of it. Maybe when you take this thing, I feel like, you know what, if you take a cylinder like this, so the remaining piece, right? I think there is some kind of symmetry here, I guess. Look at this thing. Matlab, see, you can now only guess because I got the answer. Here it is full, here it is 0, isn't it? Now, if you notice here, this is increasing. So whatever is this part decreasing here, that part is coming here, isn't it? Can you see that logic there? If I go little up, this part is this part missing here. So it's like whatever is here, I'm filling up the gaps in this part. So exactly it will be like an half filled. So you could guess something like that.
So is it like those graph paper we used to find area of irregular shapes?
Something like this. But again, that is, obvious because we got the answer, I'm guessing. Agar ye answer pi r square by 3 aaya na, I can't tell you why. So I think because you know the answer, we are guessing, but I don't know. You could have found geometrical reason. I couldn't figure out why half by looking at it. Because I know the answer, I'm setting it up for you. So that is also important. You should know. Did you actually guess or you're actually setting up an answer? Is this clear, everyone? Again, one thing I'll tell you. These things are tougher. Even your seniors have difficulty in this. Not because the integration is tough, choosing an element and everything. So really don't worry. I really want you to grasp as much as possible. These things, when they come, I will give you a brief again during that time. And these things will come at least another 4 to 5 times in physics. So every time it comes, I'll teach you once, little. So these things are tough. Choosing an element and you won't get an idea first time. You should have seen few models at least. So don't worry about it. If you understood, I think you did a good job. Now, I'm not telling you to keep you happy. That is a fact. Right? My job is not to keep you happy. My job is to make sure to make you cry here so much so that the final exam will look easy. So, but seriously, you understood, you did a good job. The result is important. Like Samek guessed it, he figured it out. If you make a cylinder of radius r and height h, and inside this cylinder, if you make a paraboloid, so we get the result like this. The volume of the paraboloid is half of the volume of the cylinder it is enclosed. There, that is how you can remember that without any integration. Volume of the paraboloid is half of,
सर लाइक अगर हमने पानी में आधा एक बकेट में आधा वॉल्यूम का पानी भर दिया तो
Yeah.
और उसको स्पिन कर दिया तो पूरे हाइट तक ऊपर आएगा फिर
मतलब हाँ सही बोल रहे हो.
ओके
मतलब if you spin it exactly, you'll get till the top and the bottom will be exactly 0. You will be able to see the bottom just like that. This is the reason why your seniors got scolded by me when they didn't remember this formula. Not because they didn't know integration. It was such a good result and these idiots didn't remember. And this would be a question in advanced paragraph. When the water is spinning, find the height and all. So it's a good result. You guys will also forget. Don't worry, I'll scold you also. It has been a tradition so far. All clear with this? Now, next one, there is one more important shape. This shape will come at least 4 or 5 times. We'll put a star for this thing. You'll encounter this thing first time, I think, in friction in 2-3 chapters. Then you'll see this in optics. Then you'll see this in electrostatics. Then you'll see this in modern physics. So 4 different chapters you'll encounter this. So what is the thing? If you take a sphere and if you paint till here, I don't want full area, only this part of it. This is theta and radius r. You're getting it? So this would be a part of a sphere. It's not a full sphere, it's a part of a sphere. You're getting what I'm asking? So this shaded area, I want the shaded area. This would be a part of a hollow sphere. We don't want the volume, we want the surface area now.
wouldn't it
Part
be a
of
lens
बोल सकते हैं वैसे भी lens. So we're asking the surface area of that, I think now. So find the surface area of the shaded part. This angle is theta, radius is r. Answer comes in terms of r and theta. How will we guess this?
तो थीटा का वैल्यू 360 रख लो या फिर 180 ले लो।
Put it in the chat box, Naregot. Don't do this, let others try. If this question comes and if there are 4 options, how will you guess this? चलो आर्य ने बोल दिया. So if I put theta 360, नहीं 360 नहीं, that is wrong anyway. Theta 180. If you put theta 180, you will completely clear. Na? See, theta 180 matlab you're covering this. 180 mein sphere will get completed. So if you put theta 180, you should get 4 pi r square. Making sense? So that is how you can eliminate options. If you put theta 90, you should get hemisphere 2 pi r square. Let's get this. How do you do this thing? This is a little tougher one, but yeah, let's try.
Sir,
Find the surface area of the shaded part. हाँ Aditi.
could you again explain the part where you made a guess? Like, for
देखो
this-
ना, theta है ना. If I make theta 90, then shape क्या होगा? Shaded area will be till where? Theta 90 कहाँ पे होगा? Here ना.
हाँ, yeah.
मतलब this will be the shaded area ना. कितना होगा shaded area for half sphere?
For half sphere, shaded area will be half of that only.
हाँ, half of 4 pi r square.
Yeah.
So 2 pi r square ना.
हाँ.
So in the options when you put theta 90, whoever gets 2 pi r square may be right,
Oh,
isn't it?
yeah.
If I put theta 180, means you're completing the full sphere.
Mm-hmm. Yeah.
Theta 180 should give you 4 pi r square. So whoever gives 4 pi r square may be right.
Oh.
But whoever doesn't give is definitely wrong.
हाँ, वो तो makes
So
sense.
we are eliminating, isn't it? We are not finding the right answer. We are eliminating the wrong answers.
All right.
If you can eliminate 3, your job's done. Think. This is a little tougher one. I'll show you. Take a minute or two. Getting an element is a little difficult in this one. You can't take disk and all. So listen.
So is there any integration for tan theta?
We have, but you don't need it here. Pi r square sine square theta.
I'm
Oh, yeah, answer
taking
आ रहा है क्या? देखो, you got pi r square sine square theta. If I put theta 90, am I getting 2 pi r square?
Yeah.
नहीं आ रहा है ना. You're getting only pi r square. So that is not the answer for sure. Something is missing.
Sir,
हाँ.
can we take a disk and use its
Ishman, put
circumference?
180 and see. If you put 180, you should get 4 pi r square. You're getting 0.
Sir, can we use a disk and use its circumference?
ऐसा ही कुछ करना पड़ेगा. Listen everyone, how to choose the element. This is a good one. I'll show you again when it comes. I'll show you at least 3 more times when the portion comes. This is your first time, so listen carefully. So from here, at an angle alpha, take a very thin slice. Let this angle be d alpha. So we get a small arc here, r d alpha. So we are taking a small slice here, d alpha. So arc length will be what? R into theta, na? So you know how will this element is looking like? So we are choosing an element like this. I'll tell you see how it looks. Imagine this. Listen carefully. Take a watermelon. Okay, listening. Take a watermelon. Cut it horizontally. You will get a disc. Now remove the red color part from the middle. Then what do you get? You get a green color band, isn't it? Are you able to visualize? Take a watermelon, cut it horizontally 2 times, you'll get a disc. Remove the red color part in the middle, you will get a green color band. Are you able to visualize? So this thing will look like this, a band. So this was the center. This was your angle D alpha, small angle. So this length here was RD alpha. This angle was R. So this length is the opposite side, which is R sine alpha. So you got a ring, like a band, like your headband, whose radius is R sine alpha and thickness is RD alpha. Now take a scissor and cut it. If you cut this and open this, you will get a rectangle whose circumference will be 2 pi r sine alpha. That will become the length. And this thickness, this will become RD alpha. This is important, right? How you got an element. So that green color band which I got, that band ka radius is r sine alpha. How did I get that? This is radius r. This is alpha. This is a right angle triangle. So this is r sine alpha. Sure?
Sir, RD alpha is the thickness, right?
RD alpha is the thickness of that thin band.
Okay.
This would be r sine alpha. This was the radius r. Because this was the center. So the dA, so the surface area of this thing, so this entire thing which you shaded, that is actually this guy only, isn't it? This is RD alpha. So the area dA, this is that area of the thin ring. This is the surface area of the thin ring. Is length into breadth, which is 2 pi r sine alpha. That is your length into breadth. Now, the first thing you will feel like, sir, how will we know this thing? That is fine. You will not know this, but now you know. So if something like this comes next time, don't mess it up. That is the whole point of it. Now you learn how to choose an element. So something similar pops up, don't mess it up. First time you'll not get it. You learn this for the first time. So this is how you handle when you get a thing like this. And then you're done actually. So you want the surface area? The surface area of that shaded part is integral dA, which is 2 pi r square integral sine alpha d alpha. The integration is actually quite easy. And what are the limits? At the center here, alpha is 0. At that vertex here, alpha is theta, isn't it? When this is alpha is rotating, look at here. The alpha is rotating like this. Alpha is 0, alpha is 20, alpha 30, 40, 50, and alpha stops here. Isn't it? So that alpha is the rotating thing. As it is rotating, alpha rotates from 0 to theta and stops. So when you have taken elements here, alpha rotates from, goes from 0 to theta. So this limits will go from 0 to theta, 0 to theta. Sine alpha ka integration minus cos alpha. Limits will go from 0 to theta. Cos 0 is not 0, it is 1. So 2 pi r square cos theta minus cos 0. The answer turns out to be 2 pi r square 1 minus cos theta. Pretty important result. Surface area is 2 pi r square 1 minus cos theta. You can check and see. If you put theta 90, you will get 2 pi r square. Put theta pi, it will be 1 minus or minus 1 4 pi r square. Please have a look at the elements.
So
Arya.
I used a disk as an element, and
This
in
the
that,
volume आएगा ना. Disk
No,
will
no.
not give you surface
I
area.
used its circumference
Okay. Then
and
thickness, what did you take?
I took thickness as dy.
That is a mistake, na? Then dy would be this thickness, isn't it? We want this, na? Slanting length we want.
Oh, right. Uh-huh.
वो मिस्टेक होगा. You need slanting length. इसलिए RD alpha लेना है. चलो अगर dy भी लेना है ना, then you should take dy and then you
So
should
I
take this
got the
hypotenuse.
answer kind of similar to this one,
You should
but
take an
it's not
element dy by
exactly.
cos. हाँ तो मिस्टेक है ना वो. Is this clear? हाँ हो गया.
You were saying something about like taking dy and then dividing it.
Now see, what I said was I need the slanting length, isn't it? So he said, yeah, I took this thing, na, dy. So if I can find this angle here, I think that will be some alpha or something. So this slanting length will be dy by cos alpha, na? But that will make your integration very tough, right? Then you have to integrate everything in terms of y. Limits will be bad, y and everything. Is this clear, everyone? How did we choose an element? Again, listen, I'll just brief it up pretty fast. So you had a thing, a part of a sphere. So from the center at an angle alpha, you took a thin slice. I'm exaggerating the figure d alpha. So we got a ring like this. I'm exaggerating the figure. I hope you're able to visualize this. It looks like your headband. Right? So this was angle alpha, this was radius r, and this was r sine alpha. And this would be the arc length, which is r into d alpha. You have taken a small angle d alpha here. So when you cut it open, you will get a rectangle whose length is 2 pi r sine alpha, and this length is r d alpha. Length into breadth gave you the area, which is 2 pi r square sine alpha d alpha. Then you integrate this from 0 to theta. You got that.
So
Clear
can
with
you show
this?
the formula, please? Thank you.
Go, take a break. Come back by 9:46. Come back by 9:47. Any doubt so far? Okay, come back in 5 minutes. Chalo, let's start off. So, how they can ask a question like this. So, example, it will be like this. Someone sprinkled, dust on a hemisphere. And what we notice, sorry, a part of the hemisphere got covered in dust. Why only part of the sphere? We'll see later on. There is something related to friction. And let's say this angle is 60 degrees. The question will be find the area covered in dust. So now, since we know the formula, it is easy to solve. So area covered in dust is 2 pi r square 1 minus cos theta. Remember, theta is your half angle. Theta is given 60. So 2 pi r square 1 minus cos 60, which is half. So the answer is pi r square. Questions will come like this. Getting the applications?
Sir, what if it is a parabola?
Then the idea to वही है, but it's a very painful thing. Parabolic area नहीं आएगा. That integration is very tough. We tried once. Then you take an element like the same story. You will take the ring like this. Now देखो, you are saying ना before. This is dy, isn't it?
Yeah.
But मुझे ये चाहिए ना. So this is dy by cos alpha.
Okay.
And this will be radius x. And ये cos alpha कहाँ से आएगा? Tan alpha is slope ना dy by dx.
हाँ.
Y से cos alpha लेके आएंगे. Then this will be 2 pi x into dy by cos alpha, and then it's very bad integration. Meaning I can get you the equation and leave it, but after that integration we won't be able to do. Meaning maybe max people can handle it. I tried it, but it was really tough, so I just left it. The limits and everything were very bad. Clear with this thing? How they can ask questions on this? All clear? Great. Next thing. Integration of a vector. So if I give you a vector and I have to integrate, how do I do that? Straightforward, just like differentiation. If you have a vector ax I cap, so that is a little bit of areas and volumes. So we have more and all, but I think those are the main things. If I give you a shape, you know how to choose an element, and then we can go ahead from that. Others, do keep your cams on. So if you have a vector like this, then someone asks you to integrate a bar dt, and then simply integrate ax dt I cap plus integral ay dt j cap plus integral az dt k cap. That's it. Just integrate each term separately and you're done. Example, if someone gives you like this, a bar is t I cap plus t square j cap plus t cube k cap, and they ask you to integrate a bar dt from 0 to 1, and this will be integral t dt 0 to 1. Just put the I cap here. Integral t square dt 0 to 1, put your j cap here. Integral t cube dt 0 to 1, put k cap here, and that is t square by 2, so that is half I cap. T cube by 3, 1 by 3 j cap, and that is 1 by 4 k cap. Is this clear, everyone? So it's not much of a different, you just different, integrate each component and put I cap, j cap, k cap, and you're done. Have a look at this. Advai, clear with this? Siddesh? Pratyasha? Shreyansh? Trishi? All clear with this? Great. Next thing. So we know velocity v is dr by dt. So vice versa, I can do like this thing. So integral dr bar is, so dr bar is v bar dt. So I can integrate this thing. So integral dr bar will give you v dt. So this will give you the displacement vector. I can do reverse also. I know acceleration. I'll give you some examples. dv by dt. I can write this thing as dv bar is a bar dt. Integral dv bar is a bar dt ka integral. We also know acceleration is another formula. V dv by dr. We'll just keep it for one dimension now. So v dv will be a dr. There. This will be the formulas there. Let me show you this thing. Let's do with a 1D thing and then we'll go ahead. Vectors integration, we will see it little later. But do you guys remember these formulas? Differentiation mein? V is dvr by dt, A is dv by dt. Same thing, if I integrate, I'll get it back. So let me show you an example, how to solve one, and then I'll ask you one more like this. So listen carefully. This will be the introduction, now we are getting into kinematics slowly. So the ending of integration is a beginning of kinematics now. So if someone gives you an acceleration, again, we are doing in 1D here, A is constant. U is your initial velocity. This is the information is given. What is initial velocity? Velocity at time 0 is called initial velocity. T is x naught is your initial position. T is time. V is the velocity at any time t. Okay. Now, first thing, acceleration. A is equal to dv by dt. We are not writing vectors, we are doing in 1D, so just normal. So dv will be a dt. Listen carefully, exact same thing you have to do it next. Now integrate on both sides. So integral dv is equal to integral a dt. What are the limits? 0 to time. Now see, you have to put limits on both sides. Try to understand the meaning of this. When time is 0, that is the meaning of this limits. T is 0, your velocity is u, isn't it? That is the meaning of this limit. So t is 0, what is your velocity? U. After some time t, what is your velocity? V. Now integrate on both sides. This is dv, so that will be v only. Limits will go from u to v. A is a constant, so this will be t. Limits will go from 0 to t. Now, if you substitute the limits, I'll get v minus u is equal to at. This is v is equal to u plus at. Ever seen this equation anywhere? This is your first kinematics equation, v is equal to u plus at. Clear with that? Next thing. Let me show it on the next page. But any doubts on this, please ask me. There. Since I got this, I got v is equal to u plus at. What is v? V is dx by dt. Send dt that side. So dx will be u into dt. plus A into T into dt. Again, integrate on both sides. This will be integral dx integral u dt plus integral at dt. Again, when time is 0, your initial position is x naught. That is given in the question. I'll just write it as x initial. When time is t, it will be x final. When you integrate this will be x initial to x final. U is constant, it comes out. T limits from 0 to t. A is constant, it comes out. This is t square by 2. If you substitute the values here, I will get x final minus x initial is u into t plus half at square. But we know x final minus x initial is nothing but displacement, which is s. S is equal to ut plus half at square. Remember this? This was your second equation in your kinematics, which you studied. This is how these things were actually derived. I know school they must have taught you with a graph or something. Another thing, we also know I can get A is equal to V dV by dx. So if I send it that side, I'll get V dV is equal to A dx. Integrate on both sides.
Sir, we can get these equations by substituting, right?
Meaning?
Meaning like accelerations formula can be just substituted there.
What is the acceleration formula?
V minus u upon t.
But how did you get that?
That's logic, maybe.
Logic.
Final
Next
velocity
question.
minus initial
Next
velocity.
question. I'll give you next question. Na logic karke answer bata. This is u to v. So when I integrate this, I'll get v square by 2. Limits u to v. This will be a. X limits will be x initial to x final. This guy will be v square minus u square by 2 is equal to a into x final minus x initial. Which is nothing but v square minus u square is 2as. That's your third equation, isn't it? Check it out. This is how you derive all your three kinematics equations. So this is the proof. We'll not do this in kinematics again. So remember, these three equations which you derived, right, are valid only when A is constant. Because A is constant every time it came out of the integral. If A was not constant, you couldn't have done this. But did everyone got the steps what we did? All clear with this? Huh, Yashvi? Clear with this?
Yes, sir.
Shreyan? Vanshika? Utsa? Clear? Aditi? Advait? Ananya? Devanshi? Perfect. Let's see a question then. Exam they'll ask you like this. This is a proper mains level question. The acceleration of a body A is equal to t. T is time. Means acceleration is not constant. When time is 0, acceleration is 0. When time is 1 second, acceleration is 1. When time is 1.5, acceleration is 1.5. So acceleration is continuously increasing with time. Your initial velocity was 3 meters per second. Your initial position was x is equal to minus 2 meters. Find the velocity and the position as function of time t. That is, find v of t and x of t. Find the velocity of the particle and position of the particle after time t. This would be a decent mains level question. Still an easy one, but still a decent one. Out of 25 questions, you might find something like 7 to 8 questions of this sort. give it a try. Don't worry about whether it is right and wrong. Whatever you think, you do it. Right. Once I show you, you can verify whether you got it right, and then see if something goes wrong. So don't worry about getting a wrong answer. That is the last thing you should be worried about while you're studying. Only when you do a mistake and you learn from it as fast as you can, you improve. Ishman, you're forgetting the limits. Get me the position. If you got the position, then you got everything right. Hmm, 6 minus 6 आया क्या?
Sir, I have taken the LCM.
Okay. हाँ, ठीक है. Continue. Ishman, that thing, t square, but that is right, Ishman. Shreyansh, right. But plus आया क्या श्रेयांश, Ishman? Plus आएगा क्या? Yeah, plus ही आएगा. Yeah, I think it is fine. Let's see. I don't remember the answer. Even I need to do. Plus 3 आएगा. Then Arya, तुझे minus क्यों आया रे? I think then you're wrong, Arya. बीच में minus नहीं आएगा.
Sir,
हो गया.
typo कर दिया.
Okay. T cube. Okay, तो पूरा common ले लिया क्या? हो गया. T cube is plus 16 by 6. 16 by 6 आया क्या? और लास्ट में और कुछ टेल नहीं आया क्या? Plus something, because I gave initial position, I gave -2. Let's see. I don't exactly remember. थोड़ा याद है. I'll have to do it. I don't remember, Rishman. Let's check. Velocity तक तो I could do it manually, but I have to do the position part. Let's see. Check it out. Same steps, huh? A is equal to T. Acceleration is dv by dt. Send dt that side. Integrate on both sides. This will be integral dv is equal to integral t dt. Limits will go from 0 to t. Now, when this goes from 0 to t, your velocity is not 0. Your velocity is going from 3 to v. Agreed? So u is 3 basically. So be careful. You can't put 0 to t and 0 to v. What is the meaning of it? When time goes from 0 to t, your velocity goes from 3 to something. Does that make sense? Now, when you integrate this, integral dv is v only. Limits will go from 3 to v. This guy is t square by 2, and limits will go from 0 to t. This will be v minus 3 is equal to t square by 2. This is your velocity, everyone. T square by 2 plus 3.
So could you explain the limits for that part again?
ये देखो ना, ये time क्या था? Time 0.
Yeah.
When time is 0, what is your velocity?
Oh, acha,
3,
that's-
na? So this should be 3 here, na? So they should be same thing on both the sides.
Okay.
Okay, and here when the time was t, velocity was some random v. Once you got this, then what? V is dx by dt. So double integration, everyone. T square by 2 plus 3. Send dt that side. So dx will be t square dt by, I'll just take half outside, plus 3 dt. Integrate on both sides. This will be integral dx half will come out integral t square dt plus 3 into integral dt. Limits will go from 0 to t, 0 to t, and be careful when time is 0, what is position? -2. So these limits are -2. That is a most confusing thing. Be careful with that limits ka part. I have seen people doing the integration well, but they goof up on the limits. When t is 0 on the right hand side, what is x on the left hand side? It is not 0, it is -2, it is given. Integrate this will be x minus of -2 is equal to, that will be half t cube by 3 plus 3 into t. Send the 2 that side, you'll get t cube by 6 plus 3t minus 2. Check. That's your position, everyone. You just have to carefully integrate 2 times and you'll get the answer. Clear with this. Check. If you got this, great. If you goofed up, see where it went wrong, get your mistake, and then you're done. You're good. Any doubts on this? Let's see one more. Turning the page. Can I go ahead? Anyone has any particular doubt there? Vanshika, Ashvi, Trishi, Utsa, any doubts? Shreyansh, Sidesh, Advait, Devanshi, Aditi. Perfect. Next one. Let's say A is equal to -2x square. At x is equal to 1, velocity is 2 meters per second. Find velocity as function of x. And remember, we know only 3 formulas. V is dx by dt, A is dv by dt, or v dv by dx. We just keep playing with these things only. Should I integrate or differentiate? Get this. V square 14. You will get v square. You'll get root of something in v ka terms mein. Try. I'll give another minute. 14 आया क्या? Cube तो आएगा. X cube is there. 14. Let's see. 16 minus 2x cube by 3. Let's see. What is acceleration? A is v dv by dx. This is an easy one, single integration, minus 2x square. So v dv is equal to minus 2x square dx. Integrate on both sides. I'll stop writing this later on. So integral v dv is equal to minus 2 integral x dx. Now be careful with the limits. Huh? He didn't say 0. At x is equal to 1, v is equal to 2. So when x is equal to 1, v is equal to 2. You can ask me, sir, why are you not putting x is equal to 0? Fine, I'll keep x is equal to 0. Do you know what is v then? You get in the problem? If you say x is equal to 0, great, I'll put it. But do you know what is the velocity when x is 0? I don't know. So you have to see the information what is given. At x is equal to 1, v is equal to 2. This much I know. At some x, you get some v. So this guy will be v square by 2. Limits will go from 2 to v. This will be minus 2. That will be x cubed by 3. Limits will go from 1 to x. This guy will be v square minus 2 square by 2 is minus 2 by 3 x cube minus 1 cube. So this will be v square minus 4. That 2 will go that side. It will be 4 by 3 x cube minus 1. So v square will be minus 4 by 3 x cube. That would be minus. How is that? Plus 4 and plus 4 plus 8 I'm getting. Weird. Yeah, there's a 3 also, no? That would be 4 by 3 plus 4. Yeah. That is 4 3 is 12. 12 plus 4 16. So v square will be minus 4x cube plus 16 by 3 ka cube. Check. See if something went wrong. Got the thing? So you can't take x0 and v something. Limits are given 1 to 2. All clear with this? Let me show you something else. So every time you won't get kinematics only, I can ask you like this also. Can I turn the page? Let's say we have a resistor, 10 ohms. Let's say some charge Q is flowing through the wire. So a few things you should know. So charge Q is given by T square by 2 plus T. The Q is the charge with time. So current in the circuit is given by, I'm sure you studied in school, current is charge flowing per unit time. So current I is given by dq by dt. And I'm pretty sure you also studied in the school, the heat produced in a resistor is integral I square R dt. This is the formula for that thing. So there, all this information I gave you, find the heat produced in 2 seconds. So through the circuit, this much current is going. So you have to need to find the current using differentiation, then put this current in this integration, and then integrate for 2 seconds. So one differentiation, one integration. Get this. So questions will be like this also. Every time you need not get only velocities and accelerations. I can bring any quantities. Give it a try. It's a little weird from what you have done, but think about it. $40. बहुत अच्छा number आया है. 98/3. You have two different answers. 40 looks very suspicious though. Nah, I could be wrong. Because maybe it could be right also. t plus 1. God, I gave you time here. 40 हो सकता है, I guess, because t plus 1 का square था वो. Could be right. Someone got 260 by 3. वो I square रहे हो गया. Maybe I ले लिया होगा तूने. 90. We have 190 and 260 by 3. Anyone else? The 260 by 3 looks more interesting. Could be right. Could be. We have one more 98 by 3. That is also fine. I'm not getting a feeling you'll get a round number though. By 3 आएगा करके feeling है. So, because there's a t square dt का integration. Yeah, but things would have gone wrong. 260 by 3. We have 3 answers. Maybe right. Let's see. So yeah, we just have to dump it in this formula here. So first of all, let's find the current. So I is equal to dq by dt. Q is given t square by 2. So half into, that is 2t by 2 plus 1, which is t plus 1. Heat is given integral I square. So t plus 1 ka square, r is 10 and dt. You set for 2 seconds, 0 to 2. 10 comes out and this will be integral t square plus 2t plus 1 dt. Limits will go from 0 to 10. This is 10 and t square dt is t cube by 3 and 2t dt is 2t square by 2 and t. Limits will go from 0 to 2. I did a 10 here, this is 2. This is 10 into, substitute there, 2 cube by 3 plus 2 will cancel, 2 square plus 2. That is 8 by 3 plus 4 plus 2, 6. 18 plus 8, 26 by 3, 260 by 3 joules. That would be the heat produced. Clear? So there's nothing there, it's just differentiation and integration, but it's not a kinematics one, it will be something else. Clear, everyone? Any doubts on this? Yeah, that's a bit about calculus here. So next class when we catch up, we will see few more models here, 1 or 2. There's also something called integration by substitutions. There are 3 models which we should kind of by heart. Whenever you see something like that, for example, if you see dx by root over x square minus a square, so there is a particular result. I like you to remember, or you should know how to do, right? Or if you have integral t into root over 1 plus t square dt. So there are a few models like this. Max may they'll teach you much more variety, but physics may, whatever I have seen, there are only like maximum 3 models there. If you know those 3, you can handle most of it. By the time more complex themes come next year, max people will teach you the topic. So then it all becomes quite easy after that. So that we will encounter, and I think after that, maybe after the break or something, we'll start off with kinematics introduction. So next class we'll start off with kinematics. So yeah, that would be our official first physics chapter. So we'll wrap up with calculus. I know we all are bored with max now. So much max. Vectors, basic math, calculus. If we continue this for another 1 week to 2 weeks, we'll think it's a max class. So anyway, so we'll start off with physics. So kinematics, that will be fun. With that, we'll wrap up for the day. And remember, there was a test online. I think today was a deadline. You should have given it by now. So any doubts, anything, you can stay back and ask, or else you're free to leave. So do make sure to revise this. It's almost 140 pages. There's a lot of theory. Definitely, resolve all these integration questions once more. So those are doubts, stay back. Other stuff